Okay, you guys, we're going to talk a little bit about horizontal asymptotes for what our unit is right now, which is rational functions. Sorry about the bad handwriting. I haven't done this in a second. But what we know about horizontal asymptotes, it's the same for any type of function. We're just going to find them for rational functions. And what that means is a place in your graph or a number in your graph that your function or your curve will approach but never ever actually touch. Okay, so the function doesn't actually exist there, but it will get super, super close. It'll approach a distance of 0 between them, okay? So this is our parent function, just a quick review that I just drew, 1 over x. And our horizontal asymptote is right here at x equals 0, because this curve is going to forever get close to 0 here on both sides, but it's never going to actually cross the x-axis here, okay? So it won't exist. So x equals 0, where it will never be, is the horizontal asymptote. But there's 3 kind of like different ways to look at rational functions. The first one is that the degree of the numerator is less than the degree of the denominator. 2, the degree of the numerator equals the degree of the denominator. And 3, the degree of the numerator is 1 more than the degree of the denominator, okay? So if we take a look at this, an example for the first one, the degree of the numerator is less than the degree of the denominator, could be x squared over x cubed minus 4x squared plus x minus 2. Okay, the degree on the numerator is 2, and the degree on the denominator is 3. Remember, it's the highest exponent. So that matches the first one. Okay, the second one, the degree on the numerator equals the degree on the denominator. Could be x squared plus 4x minus 2 over x squared plus 3x minus 4. Okay, and there our degrees are the same. Okay, and the last one, the degree of the numerator is 1 more than the degree of the denominator. Yeah, let's do x squared minus 4x plus 5, and then this needs to be less than, so we're just going to have like 3x minus 2. Okay, so for 2 of these, there's going to be a trick to it. 2's terrible, isn't it? For 2 of these, there's going to be a trick to it. And for the third one, we're going to have to do something called long division using polynomials, which will be a separate video that you can watch. But for now, let's just take a look at it. For the first one, where the degree on the numerator is less than the degree on the denominator, your horizontal asymptote, let's put some more color here. Let's do blue for I. So for just the first one, your horizontal asymptote is always going to be x equals 0, okay? Just like our parent function, the degree on the numerator is less than the degree on the denominator. The degree on the denominator is x to the first power, right? And the degree on the numerator, well, it doesn't actually have one. Actually, it does have one. You can put it in. It would be 1 times x to the 0 power. Remember, anything to the 0 power is just 1. So 1 times 1 is going to be 1. And that makes the degree on the numerator less than the degree on the denominator. So if that ever happens, just think about your parent function. Your horizontal asymptote is always going to be x equals 0. These shortcuts will really come in handy on your SAT if it gives you something, because remember that SAT is all about how fast you're getting through it, as well as how well you're doing, but the faster you get through them, the more chance you have of getting answers correct. Okay, that kind of sounded funny. What I meant was the more you do increases your chances of getting more correct. Keeps coming out wrong, but hopefully you understand what I mean. Let's take a look at the second option down here, which is the degrees are the same. Let's make those pink. So for option 2, the degrees are the same. This is kind of a fun one to look at. For this one, you're going to look at the coefficients in front of the degree. So actually, I'm going to change them. Let's make this 4x squared, and then let's make this 5x squared in the denominator. That looks like a negative, but it's nothing. So we look at those. We have 4 and we have 5. When they're the same, and you're looking at the coefficient that is in front of the degree that we are working at. So we're only looking at the 4 and we're only looking at the 5. We're not looking at this 4 and this 3. We're not looking at this 2 and this negative 4. We're looking at this 4 and this 5. That makes our horizontal asymptote x equals 4 over 5. Okay, you just take the coefficient on the numerator of the highest degree and you divide it by the coefficient of the denominator that is of the highest degree. Okay, so those two are pretty easy. And actually, I think I'll make the last one a separate video so you can watch it when you're ready to watch it if you want to practice these two types. Or if you want to watch the video for doing the long division, that'll really help out when we do this video where we're looking at the degree as one more on the numerator than the denominator, because we're going to have to use that division. So I'm going to stop this one. You can do some practice problems if they're like this for the horizontal asymptote, and I will make one of those other ones.